Hello viewers, my name is Geoffrey Omondi and I'm going to be taking you through the topic probability. Probability. Now, this is a Form 3 topic in Kenyan secondary syllabus curriculum. And in this topic today, I'm going to look with you what we call introduction, and also look at what we call experimental probability. So this is today's class. So this is what we are going to look at today's class, introduction and also experimental probability. So I want us to start straight away with introduction to probability. Introduction to probability. Like that. Now, when we talk of introduction to probability, I want to believe that some of us, if not all of us, have actually heard of this word probability in the past. Some have not heard of it as a lesson, but they have actually used it by extension, either knowingly or without knowing. So when you talk of probability, normally what should come into our mind straight away is how probable. Now, this alone may not be of much help to someone who in itself doesn't understand what probability is, but I believe this is going to help us. Now, let us look at a few scenarios. So I want us to look at a situation where, for instance, number one, you want to find, so what is the likelihood that if a coin is tossed once, what is the likelihood that if a coin is tossed once, the result will be a head and not a tail? So that is one scenario I want us to look at. The second scenario which I want us to look at, what is the probability that we will one day die? What is the probability? Is the probability, or what is the chance? What is the chance that any given human being will one day die in the future? Now, I want us to look at a third scenario. Suppose without going outside the room, you don't know the weather condition at all. You are asked again this third question. What is the chance it will rain today? Yes. So what is the chance that it will rain today? Still, we can look at a last one. We all know what die is, or a dice, when we are talking of plural. You can be asked again, what is the probability? Let us not use that first. Let's say, what is the chance what is the chance that a die, die in plural is normally what we are referring to as dice. So what is the probability that a die thrown will give a 2? Now, I want us to look at this 4 scenario. That is what we are going to use so that we can understand the meaning of probability. Now, for instance, when we say, what is the likelihood? So, we are considering the scenarios. So, we are considering the scenarios. So, what is the likelihood that if a coin is tossed once, the result will be a head and not a tail? Now, when you look at, for example, a coin, what we have there is that a coin, normally, we only have 2 possible chances. It's either you are going to get a head or you are going to get a tail when you toss a coin. Now, bearing in mind that we only have 2 chances, these are 2 chances, it means that tossing a coin, for you to get a head, you will have 1 out of the possible 2 chances. So this is a head. Let me use H to show head, and let me use T to show tail. But when you want to get a tail, again, the chance is that you will have only 1 chance out of 2 chances. So therefore, we can say that the chance that by tossing a coin, you'll get a head is actually 1 out of 2 chances. Still, by tossing the same coin, the chance that you'll get a tail is 1 out of 2 chances. Let us consider the second one. What is the chance that any given human being will die in one day in the future? What is the probability that any human being will one day die in the future? Now, from experience, we know that human beings at some point die. So if we are asked what is the probability that one will die, then there's absolute chance that one will die. In a situation where we have an absolute chance that one will die, we cannot give it as a fraction. We are trying to say that if the probability of death is maybe 100 years, over 100, you will die, then chances are whatever years you take, somehow you die. So this is called certain chance. This is certain chance. So in that case, the chance is 1. And we are saying that 1 normally refers to a certain chance. You have to die at some point, bearing in mind what we have been experiencing in the past. Someone has to die. Now, we can also consider the third one. What is the chance that it will rain today? Now, there are only 2 things here. Either it's going to rain or it is not going to rain. And remember, when I was writing this scenario, we agreed that you are not aware of any weather condition. So the chances that it will rain or not rain. So in that case, we are only dealing with 2 possible outcomes: will rain or will not rain. So in that case, therefore, we can say that the chance that it will rain is simply 1 out of the 2 possible chances that it will rain or it will not rain. Now, in the 4th scenario, what is the chance that a die thrown will give a 2? Now, those of us who know what a die is normally a cube with 6 faces, and each face is marked 1, 2, 3, 4, 5, or 6. So when you throw a cube, the chances are that any one face will come up. You cannot have 2 faces facing up at the same time. So any face that you are talking of, is 1 out of 6 chances. Allow me to clean here. Now, in these cases, therefore, these scenarios which we've considered, this was the first one, you realize immediately that our chance can be experienced in a numerical way. We can write our chances in a numerical way. Now, that chance that can be written in a numerical way, that is what we are calling probability. So we can therefore say that probability refers to a chance expressed in numerical values. So probability refers to a chance expressed in numerical values. And we are saying that these numerical values could be values like, example, values like in the first case, number 1, it was value like a half. In the second instance, we had a certainty, which is 1. In the third instance, we had a half. In the fourth instance, we had a sixth. Now, note, therefore, that probability ranges between a certainty and impossibility. Now, in that case, therefore, I want us to note the following one. A certain chance has a probability of 1. Written like that, 1. We also have an impossible chance. For example, if today is Monday, what is the probability that tomorrow is Wednesday? Now, that is not possible. If today is Monday, it is only possible that tomorrow will be Tuesday, and it can never be Wednesday. So if we say that if today is Monday, what is the probability that tomorrow is Wednesday? In such a case, that is an impossible chance. So an impossible chance has a probability of 0. An impossible chance has a probability of 0. In other words, all our probabilities range between 0 and 1. All our probabilities range between 0 and 1. So we can give that as the note and say that all probability can be 0, 1, or any fraction or in between 0 and we are saying these are the 3 things that are very important. A certain chance has a probability of 1, an impossible chance has a probability of 0, and all probability can therefore only work in the range between 0 and 1. For instance, let me just clean here so that we get this clearly. For instance, we cannot have a probability of 3. We cannot have a probability, say, of 2. All probability have to be within 0 up to 1. And we are saying that a probability of 0 means that there is no chance that that event will take place. And probability of 1 means that it is certain that an event has to take place. So I want us to look at what we call experimental probability. Probability. probability like that. Even as we look at experimental probability, let's remember we have said that probability is simply chance expressed in numerical values. So when you use numbers to express a chance like a half, 1, a half, 1/6, in that case you are talking of what we call experimental probability. Now, experimental probability, as the name suggests, is chances of occurrence known as a result of carrying out an experiment like that, or from experience. So simply, this is what experimental probability means. So these are chances of occurrences known as a result of carrying out an experiment or from experience. For instance, you can be asked, let's look at a scenario. If we are in March currently, what is the probability that it will rain in June? Now, we can clean here so that we continue from this other side. Let's just clean there lightly. Now, when you look at this statement carefully, it requires someone who has been living in this area and know the pattern of rainfall in June. If you are a complete stranger, you've never lived in this area, you don't have any data to back up what you're going to say, you may not find the probability. Now, in this case, it depends on the data that has been there over the years. Is it common? Is it frequent that it always rains in June? Or is it frequent that it doesn't rain in June? Now, if our probability, for example, we can now go to data and look at over the past years, and we can realize that in most instances, it always rains in June for, say, 17 days. Then, using this information, which is data now, we can say, therefore, that June has a total of 30 days. And therefore, if it normally rains for 17 days, then our chances of a rain in June will be 17 out of 30. Now, this 17 out of 30 is what we are now calling an experimental probability. The reason is we are using our past experiences and we are using experiment that is already recorded as data to determine the probability of it raining in June, Allow me to give us an example. This is KLB. Book 3, 4th edition. So this example is from KLB, book 3. And then this is 4th edition. So this is the example we are going to use. So example. So we can write that example this way. A boy has tossed a fair die, Now, a fair die means this is a die without any defect. Chances are, if chance of getting any face is equal, that is what we mean. So a boy has tossed a fair die 50 times. 50 times. The table below shows result of his experiment. So we have a table which we can draw. We have a table which we can draw like that. We have a table. So this is face. So number of times. Allow me to write that way. Number of times. Number of times the face shows. Face shows up. Face shows up. So we all know that a fair die has 6 faces. It is a cuboid. It is a cube. So this is 1, 2, 3, 4, 5, 6. So anytime you throw, you can get the first face, or the second face, or the third face, or the fourth face, or the fifth face, or the sixth face. So you normally know. For example, the first face only has 1 dot. The second face has 2 dots. The third face, 3 dots. The fourth face, 4 dots. The fifth face, 5 dots. And the sixth face, 6 dots. So in this case, the first face, out of the 50 throws, he got face 1 11 times, face 2 6 times, face 3 7 times, face 4 9 times, face 5 also 9 times, and face 6 8 times. Find the probability. This is the question. Find the probability. Find the probability of getting. Find the probability of getting A 1, B 4, and C 6. So I want us to try this and see. Let me just clean here. Just clean here. Now, when you're given this, you have to ask yourself, what is the probability? And what is the total chance? So you look at the event and say, now we want A. So we want the probability of this boy finding face 1. Now, we know that to find face 1 out of 50 throws, so the number of trials in this case were 50, and the outcome that he got as face 1. So face 1 outcome were 11. So in this case, you will know that to get this, we will get the face. So the probability of getting face 1 would be the total outcomes of phase 1 divided by the total number of trials. Total number of trials. So in this case, therefore, we will say that this will now be 11 out of 50, like that. So the chance that is going to get phase 1 is 11 out of 50. What about phase 4? Phase 4, again, you will say the probability of getting phase 4 is actually the total number of outcomes of phase 4. So outcomes of phase 4 over the total number of trials, which in this case were 50. Total number of trials. So in that case again, what we are going to end up with, now, phase 4 were gotten 9 times. So the outcomes for phase 4 were 9, but the total trials, this boy threw 50 times. So the total trials were 50, like that. Now, lastly, we can look at C. We can look at C. I can write this side so that you are able to see. So C, what is the likelihood of getting phase 6, written as probability of 6? Again, in this instance, I will say that this should be the total outcomes of phase 6 over the total number of trials, total number of trials. Now, when we check here, phase 6, the total outcomes were 8 over the total number of trials, which were 50, like that. So in general, we can conclude by saying, let me clean here. In general, we can conclude by saying, in general, we can conclude by saying, in general, so in general, we can say that probability of any event X, is equal to the total outcome of X over the total number of trials. So the probability of any event X, probability, let me write this as the probability of any event X. To say that this will be given by the total outcome of X over the total number of trials. We can look at another example. Yes, so we'll clean here to look at the other example. Clean here to look at the other example. So this example is from KLB. This example is from KLB. Exercise 13.1, number, it's from KLB, exercise 13.1, number 3. I want us to look at that example. And that example states that statistics have shown that out of every 38 bulbs, this is 1,000. Out of every 1,000 bulbs, 38 of certain type burn out in 6 months. Like that. Find the probability that a bulb will not burn out in 6 months' time. Find the probability that bulb will not burn out in 6 months. Now, looking at this keenly, we can, let's wrap here. We've just said that the probability of any event X, we say that you look at the likelihood or the chance or the total outcome over total number of trials. Now we can modify this a little bit to fit into our situation. So we are looking at solution. So we are looking at the probability that a bulb will not burn out. Now, the probability that a bulb will burn, so let's say probability that a bulb will burn, let me just write it in full so that we see. Probability that a bulb will burn out in 6 months is actually 38, which is the total outcomes, over the total here, which is 1,000 experimental bulbs. So looking at that, that becomes our probability that a bulb will burn. But what if we want a situation where a bulb will not burn? It means that if 38 bulbs burn out of 1,000, then it means that there are a certain number of bulbs that did not burn. So in that instance, we'll have 1,000 minus 38, giving us 962. So it means that 962 out of 1,000 bulbs did not burn. Now, this 962 out of 1,000 bulbs that did not burn actually gives us the probability, this gives us the probability that a bulb will not burn in the next 6 months. Now, learners, it is important to know that normally when you're giving your probability, in a situation where you have fractions that are that can be reduced by simplification, normally you are advised to simplify. For example, in this case, you have 962 out of 1,000. It is important to know that, for example, both of these numbers are divisible by 2. So we can divide 960 by 2. This will give us 48,1, like that, over 500. So this 962 over 1,000 is actually similar to 481 over 500. This is called simplification of fractions. Now, that should be bringing us to the end of our today's class. I want to leave an assignment for us. Now, like we normally tell you, when we leave an assignment, there is the comment section just below every video you're watching. Like now, you can see comment section just below it. Please make sure that if you're not able to attempt any question, can you give us your feedback by responding just below this video so that we can respond and come back to you and help you solve it out. Otherwise, the assignment I'm leaving is still in KLB. Exercise 13.1. Exercise 13.1. We have number 1, number 2, number 4, number 7, number 8, number 9, and number 10. And I'm encouraging you, if possible, please, in every exercise, try to do everything so that you give yourself enough practice, because these exercises are meant for the person at your level trying to learn these concepts. So try to learn everything and be free to give us suggestions. Be free to tell us what you are not able to solve in the comment section so that we can respond and help you. My name is Jeffrey Omondi. Thank you and bye-bye.